Assalamu alaikum warahmatullah. This is Javed Ahmed, mathematics teacher at MET Higher Secondary School, Sopor. In this lecture, I would like to discuss with you an important concept from class 9 mathematics, and that concept is a relation of congruence between the triangles. This concept is an important concept which exists between two or more than two triangles in certain condition, and the condition for existence of such a relation is that if all the elements of one triangle are equal to. Now remember this thing, I am using the term are equal to the corresponding elements of another triangle. When such a thing happens, we can say that two triangles are in the relation of congruence with each other. Now, before elaborating this statement, as you can see, I used the two terms here, that is elements of a triangle and correspondence between the elements. So we'll discuss these terms first, that is elements of a triangle and the term that is correspondence. Now you know that a triangle is a polygon of three sides. So if we try to draw a triangle, we'll take the help of three line segments which will meet at their endpoints and will give us a closed figure like this, and we'll name this closed figure as figure ABC and call it as a triangle ABC. Similarly, we'll draw another such figure with the help of three more line segments, and we'll call this figure as triangle DEF. Now you can see in triangle ABC the three line segments which are involved in the formation of this triangle ABC are line segments AB, BC and line segment CA. These three line segments are called the sides of triangle ABC. And you can also see here that at this corner a pair of line segments, that is line segment AB and line segment AC, meet at this point. This point where this pair of line segment, that's line segment AB and AC, meet, this point will be called as the vertex of triangle. Similarly, this pair AB and AC meet at this point B, this will be called the vertex B of triangle ABC. And similarly, we can call this point C as vertex C of triangle ABC. So in this triangle, we have the three vertices: vertex A, vertex B, and vertex C. Now, at vertex A, you can see that this pair of sides, that is side AB and side AC, diverge from this point A. And this divergence between the sides of this triangle ABC, that is side AB and side AC, this divergence will be called as angle between the sides. So we have angle A here, angle B here, and angle C over here. So in this triangle we have angle A, angle B, and angle C. Now all these three sides, these three vertices, and these three angles will be called as the elements of triangle ABC. In the same manner, in triangle DEF, the line segments DE, EF, and DF will be called the sides. Point D, point E, and point F will be called as the vertices, and angle D, angle E, and angle F will be the angles involved in this triangle DEF. So these will collectively form the elements of triangle DEF. Now moving on to the correspondence between the elements. As you can see in these two triangles, side AB and side DE go along the same direction. So we can say that side AB of triangle ABC and side DE of triangle DEF are in the same sense. So the sides which are in the same sense will be called as the sides corresponding to each other. So we can say that the side AB corresponds to side DE. Similarly, side BC and side EF go in the same direction, or we can say that the side BC and side EF are in the same sense. We can say that these two sides are corresponding to each other, and then the sides AC and DF will be corresponding to each other. Now we'll write this correspondence in the notation form as AB corresponds to DE, BC corresponds to EF, and AC corresponds to DF. Then angle A will correspond to angle D, as angle A is in the same sense as angle D is, and angle B will correspond to angle E because this pair is also in the same sense. Angle C will correspond to angle F. This pair is also in the same sense. Then vertex A will be corresponding to vertex D. Vertex B will be corresponding to vertex E, and vertex C will be corresponding to vertex F. Now in these two triangles, we find that these elements of triangle ABC and these elements of triangle DEF are corresponding to each other. Now if we read the statement carefully, it reads that if all the elements of one triangle are equal to the corresponding elements of another triangle, then two triangles will be set into the relation of congruence with each other. Now, according to this statement, we can write that if AB is equal to DE, BC is equal to EF, AC is equal to DF, and angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F, then we can say that two triangles are congruent to each other. Now, for these vertices, you know that the vertices are the points, and the points are always equal in any pair of the triangles. So the sufficient condition for the existence of the congruence between the triangles is that three sides of one triangle must be equal to the corresponding three sides of another triangle, and three angles of one triangle must be equal to the corresponding three sides of another triangle. Then if such a condition, such a situation happens, we can simply say that triangle ABC is congruent to triangle DEF. Because all the corresponding parts of triangle ABC are equal to the corresponding parts of DEF. Now, this statement is written in the condensed form as such by using the symbol of congruence between the two triangles, and the symbol of congruence is like this: equality with a twiddle over it, and we write triangle ABC is congruent to triangle DEF. So when two triangles are congruent according to this statement, then if we take this triangle ABC and superpose this triangle ABC on DEF, it will fully cover this triangle DEF, and these two triangles on superposition will appear as a single triangle. Then at that time we say that triangle ABC is congruent to triangle DEF. Now